Okay, we're doing 10-1 Part 3 today on radical expressions and functions. And we're doing objectives 7, 8, and 9. That is, simplify expressions of the form cube root of a cubed, find even and odd roots, and simplify expressions of the form nth root of a to the nth. Page and get into it. So we're going to simplify cube root of a cubed. The definition here is for all real numbers a, the cube root of a cubed equals a. That's without absolute value symbols. When we did square root of a squared, we had got the absolute value of a. But now cube root, that doesn't matter. And that comes from, because we can get a negative number. If we cube a negative number, we get a negative number. So we don't have to have the absolute value. So let's look at number 7, or example 7. You got the cube root of negative 64x cubed. If you have to remember back to from part 2, your common cube roots, the cube root of 64 is 4. And so we can do a cube root of a negative number. So we're going to get, our answer is going to be negative, cube root of 64 is 4, and the cube root of x cubed, the cube root cancels out with the power of the cube, so it's going to be negative 4x. Now I want to do another example because there are problems that, just like in our square root problems, we had fractions, taking the cube root of a fraction. So we're going to do example 8, and I want to do the cube root of, say, 8 over 125. And we did this with square roots, but I wanted to show you that it can be done the same way with cube roots, and that is we can cube root the top of the fraction and cube root the bottom of the fraction separately. So we can take the cube root of 8 over the cube root of 125, and what that gives us is 2 over 5. Okay, so that's our answer. Now, stop, pause here, try the checkpoint, and when you come back, I'll give you the answer. Okay, the answer is negative 3x for checkpoint 7. Let's move on to even and odd nth roots down at the bottom here. On the side here you can see we've got common roots for 4th root and common root for 5th root. There are other roots, there's 6th, 7th, and so on, but we're going to only work with squared, cubed, 4th, and 5th. And these problems are pretty simple. 4th roots obviously are even. 5th root would be odd. And if we're going to do 4th root of 81 for problem part A of example 8, 4th root of 81, we just look up on the chart, 4th root of 81 is 3. For B, the negative 4th root of 81, that's going to be negative 3. For C, though, the 4th root of a negative number, if it's even, the root is even, like because we're doing 4th root and that's even, then we cannot take the 4th root of a negative number. Sorry. We can't take the even root of a negative number. So this one is not real. And D, though, an odd of a negative we can take, an odd root of a negative number. So the 5th root of negative 32 we can take, and we look at 32 and the 5th root is 2, but since it's a negative 32, the answer is negative 2. Stop, pause here, try the checkpoints. When you come back, I'll give you the answer. All right, checkpoint 8A equals 2. B equals negative 2. C is not real. And D is negative 1. Let's turn to the next page. Alright, so we're going to simplify expressions of the form nth root of a to the nth. And it says, we have seen that square root of a squared equals the absolute value of a. And the cube root of a cubed equals a without the absolute value. Expressions that says expressions in the form nth root of a to the nth can be simplified in the same manner. It says unless a is known to be non-negative, absolute value notation is needed and when n is even. So if we're taking the nth root of an even root, if we're taking an even root, we have to use absolute values. If we're taking an odd root, we don't need them. And that's what this says down here, the definition, simplifying nth root of a to the n. It says if n is even, so these numbers here are even, we have to use the absolute value symbols. But if n is odd, so that means these are odd here, you have to use you don't have to use the absolute value symbols. So let's look at how that works. We've got example 9 here. A, we're taking the fourth root of x minus 3 to the fourth. N is definitely even. We're going to need the absolute value symbols. And just like with square roots, fourth root will cancel out a fourth power, and we're going to get the absolute value of x minus 3. B, fifth root of 2x plus 7 to the fifth. It's an odd root now. We don't need the absolute value symbols, and the fifth root will cancel out with the fifth power, so we get 2x plus 7. And C, we got sixth root of negative 5 to the sixth. We have an even root, and so we're going to have the absolute value of negative 5, because the sixth root will cancel out with the sixth power, but we can figure out the absolute value of negative 5. That's just 5. And that is all for 10.1 Part 3. I will give you your homework tomorrow.